Okay, let's move on to the coordinate pairs. Okay, so let's remind ourselves this is a unit circle, right? Because on the graph paper, this big old circle is actually this tiny circle with a radius of 1. So let's fill out the points that are really easy, which are the corner points. And I will highlight them right here. So these are the corner points. Boom, right there, and right there, right? And we know that this is 1, 0. At the top, it's 0, 1. At the left side, it's negative 1, 0. And at the bottom, it's 0, negative 1. So let's fill those in. The top is 0, 1, negative 1, 0, and 0, negative 1. Okay, so now we need to figure out all these other coordinates. Okay? And to do that, we're going to need to use our knowledge of right triangles. So I'm going to show this on the back side of this paper. And I just copied the unit circle here, so that so I don't have to go back and forth and refer to it. Okay, so let's do this. Let's first talk about this angle, this triangle, or this angle right here. Or I want to focus on, this is my focus. This one right here. I want to focus on this coordinate pair, which is this dot. Okay. Now to figure out what the x and y values are, right, for this coordinate, really the x value is how far do I go to the right, and then from there, how far up do I go? So do you guys see this triangle that we just made here? And let's fill in some information about this triangle. Well, we know this is 90 degrees. We know this is 30 degrees, right? Because that's what we said over here, 30. And this must be 60 degrees then. Now, remember in the beginning of this chapter, we talked about special right triangles. And right, that's the reason we talked about that, is so that we can complete this unit circle much better. All right, so another piece of information about this unit circle, if you guys remember, what is the radius of this circle? Guys, remember that the radius is 1, right? And check this out. Right here is the radius, right? Going from the center to the edge of the circle. That is the radius. So this hypotenuse has a distance or length of 1. Really cool. Now, do you guys remember your special right triangle rules? Right? If you have a 30, 60, 90 triangle, if you have a 1, or if you have a hypotenuse, we know that the short side here, they have a relationship, right? We know the short side is half of the hypotenuse. So this length is 1/2. And then finally, to find the long side, you take the short side and then you multiply by square root of 3. So this becomes 1/2 times square root of 3. Or, if I were to clean it up, it's actually square root of 3 divided by 2. This is the better version, right? So I'm going to write square root of 3 divided by 2. Okay. And so let's fill in this coordinate pair then. Well, what is the x value? Well, that's the horizontal length. That's going to be square root of 3 over 2. And the y value is going to be the vertical, which is 1/2. Awesome. Okay, we got one of them done. And then, so let me erase this part. Okay. So now, if I know this coordinate pair here, this one over here is really easy to find. Okay, the reason being, well, what's the angle? So for this point, here's a new triangle using the same ideas. We know the hypotenuse is 1 and the angle is 60 degrees. So we know that this is 60 degrees and this is 30. Well, this is just another 30, 60, 90 triangle. And so we know the short side is 1/2 and the long side is square root of 3 over 2. So let's fill in our x and y. The x value is the horizontal, 1/2, and the y value is root 3 over 2. So if you compare this coordinate pair with this coordinate pair, we know that they're the same numbers except their x and y's are just flipped, right? Okay, so that's nice. All right, so we just have one more now then. We just have this middle one. And let's erase the highlighter here and mark this one because we need to focus on this one now. Okay, so how do we do this triangle or this coordinate pair? So this coordinate pair, and I'm going to erase this triangle here. This coordinate pair can be found by making a triangle that looks like this. And what kind of triangle do you think this one is? Well, this is a 45, 45, 90 triangle with a hypotenuse of 1. All right, so I'll make another triangle here to show my math calculations. Here's one. This is a 45, 45. If you remember our special right triangle rules, what basically happens is the long side, if you want to go backwards to figure out the short side, we divide it by square root of 2. All right. But for the sake of not just memorizing, let's actually use the Pythagorean theorem to figure out what the side length is. So we know this side length, they're equal on both sides because 45, 45, 90 triangles are have the side lengths be the same. So Pythagorean theorem says a squared plus b squared equals c squared. A is x squared and b is the other side, and so c is the hypotenuse, and there we go. So if we clean this up, we have 2x squared is equal to 1. To get x by itself, I'm going to then divide by 2 to get x squared is equal to 1/2. And to get x by itself, I'm going to square root both sides. So I have x is equal to, the square root of 1/2. But if I were to clean it up, it's actually going to be 1 over the square root of 2 because, so basically if you square root a fraction, you can split it up into the square root of the top divided by the square root of the bottom. And we know the square root of 1 is just 1. And so what we're left with 1 over root 2. Now, for the unit circle, people don't like this radical on the bottom. Don't like roots on the bottom. Okay, so we need to clean that up. So what the mathematicians do is really, really clever. So they start with this 1 over root 2, and they actually multiply by 1. And we know if you multiply anything by 1, it doesn't change the value, right? So what do we mean by multiply by 1? Well, what they actually multiply by is a fraction that's the same on the top and the bottom. You see that? Now, why did they choose root 2 over root 2? Well, now you have a fraction problem where you multiply two fractions. So the tops multiply together to get root 2, right? 1 times root 2 is just root 2. And what's root 2 times root 2? Turns out that's root. And what's 2 times 2? 4. And if we simplify that, it becomes square root of 2 on the top over, what's the square root of 4? 2. And so this is what it turns into. That's a lot of work, right? So let's just, let me rewrite this. So this x is the square root of 2 over 2, and so is this one, square root of 2 over 2. All right, so all this work using the Pythagorean theorem, that I just want you to know that's where it comes from, but really, you really need to memorize that root 2 over 2 is the x and y value, or the the side lengths, right? So let's go back to this triangle over here on our unit circle. We said our side lengths are root 2 over 2 each. So that's what our x and y's are. Okay. All right, so let me clean up this right here to give us a little bit easier time to see. Okay, so what I want you to do, and I'll just write these two as well. I want you to take a moment and look at patterns here, because eventually we're going to need to memorize this. But what do you see here as a pattern? And I'll write down some of these ideas. Well, one, we see that 2 is the denominator for all of them, right? If you notice, divided by 2, they're all over 2. So that's nice. Another way that helps me kind of remember is, hey, it's easy as 1, 2, 3. And you guys notice right here, 1, 2, 3. And the other way is 1, 2, 3. So that helps me remember or kind of memorize this unit circle. And just got to know that, hey, these all have square roots at the top. All numerators values have a square root. And I guess if you think about it, this technically is a square root too, right? Because what is the square root of 1? It's just 1, but we just don't write the square root. So, you know what I mean? Like, they all have a square root. So if you use the patterns to remember, it helps you memorize this a lot better. All right, so we got, that's a lot of work, right? We got one quadrant done.